Welcome, everybody, to the Open USD Insiders live stream. Very excited to be joining you today with our very special guest. We're coming hot off of GTC. Still a lot of energy in the air from that. I'm sharing on the screen some of the announcements we made at GTC in case you missed our live stream last week when we took a deep dive into some of these things. Feel free to go back to our YouTube channel under the live section, and you'll see that live stream there. Or you can also check out this forum post, which we'll post in the chat as well, which kind of goes over each major announcement related to NVIDIA Omniverse. Super exciting stuff. So I highly recommend that you check that out. But today we are very excited to have an Isaac Sim office hours again. These are such exciting events, and so happy for the team to joining us here today to do this. As you know, in the community, Isaac Sim and robotics in general is such a hot topic across all of our platforms, the forums and Discord. So these sessions are meant to help the users. So you out there watching, ask your questions live of our experts on the team. We'll also spend a little bit of time going over a feature of workflow. So I think the team has something prepared to show off today. But you are now fully in the Isaac Sim office hours. So this one's going to also focus on ROS 2 workflows. So whether you're just diving in, you have some very basic questions. Don't worry about it if you think it's a simple question or too easy. There is no such thing. So to ask whatever you like. And even if you are a super veteran expert and you need deep dive answer on something, if we can't help you on a live stream, we'll make a note of it and we'll probably create a forum post afterwards. That being said, let me introduce our fantastic guest here. No stranger to the live stream, to my side over here. How you doing?
Hey Edmar, hey everyone. Rishabh, nice to meet
You put together some great content for GTC, so congratulations on that.
you. Thank you. Yeah. Hey everyone. Glad to have all of you here, and we've got Ayush as well, who's joining us today. And hopefully, we're going to be taking a deeper dive into some of the ROS workflows which IsaacSim enables, and we'll be here to answer your questions. And I'm Rishabh. I'm tech marketing engineer for IsaacSim, and worked with the ROS2 bridge a lot with IsaacSim, but we have Ayush here who's like worked on the development side and can give us more insights in terms of the how-tos and the nuts and bolts of using ROS with IsaacSim. So over to you, Ayush.
Thanks, Rishabh and Edmar. It's great to be here. I'm happy to answer all of your guys' questions. My name's Ayush, and I am kind of the lead developer for ROS for IsaacSim. So any of the ROS Bridge stuff, I have worked on it a lot. So happy to help.
Awesome. We're already seeing some great excitement in the audience here. I have over 100 people watching already. So I'm going to let my colleagues here, Rishabh and Ayush, go ahead and take things away. I will be in the background. I'll help with some of the chat, and yeah, have a great office hours, everybody. Thanks for joining.
Thanks, Edmar. Hi, Ayush. So I think like we discussed earlier, like if we before even like looking at the questions or in general like the stuff you had, you mentioned there are a few advanced topics like which you wanted to cover in terms of like workflows. So do you think now is a good time to get started with that?
Yeah, let's go for it. So I just wanted to quickly cover namespaces in IsaacSim, and there's a new way of doing namespaces now. So we want to be, let me just share my screen. There we go. It's probably taking a minute to load.
Oh, okay.
There we go.
Yep.
Awesome. Okay. So all I have here is IsaacSim 4.5 on the right and a terminal on the left that's ROS sourced. And the thing I wanted to cover really quickly is namespaces. So here I'm just going to add this Turtlebot robot here into the stage. That's nice. Now, if you hit play, this Turtlebot already has a bunch of these graphs set up inside it. And if I do a ROS2 topic list, you can kind of see all these topics, which is, awesome. Now, what if you wanted to have multiple Turtlebots or, multiple robots in the scene? Usually, the way we solve this issue in ROS is to add namespaces. The way we had been doing things before is to go into the graphs and manually add namespaces inside each of the ROS published nodes. For example, one right here would be like the subscribe twist. There's like a node namespace option here. You would manually fill that in, and you would have to manually fill that in for all the different nodes that are in the graph. So instead, we have this new feature in Isaac Sim 4.5 that I just wanted to highlight, and that's automatic namespacing. So super easy. The first way, the way to start this is you go click on your root level of your robot. So in this case, it'd be Turtlebot 3 Burger ROS, and click Add, and then click on Attribute, and then once you do that, set your name to Isaac namespace. This is important because this name, the simulator actually looks for it, and then it'll do some magic in the backend to handle this. And then we also have to make sure that the type is string and set this to custom, and then you just click Add. So now that you have added this attribute, just go into the property panel again, make sure you're clicking on this, and then scroll down until you can find the attribute right here. And I can set this to anything I want. So for now, it should be empty, so no namespaces. So if I stop and play again, and I run ROS to topic list, you'll see it's all the same. If let's say if I now type it in, let's do TB3.
Ayush, quick question. Did your simulations... Oh, okay, stopped right now. It was playing. Yep, sorry, good.
Yes. Good catch. Yeah, so it's stopping now. And I will play again. So now I have the namespace configured right here. It's set to TB3. So if I do a ROS to topic list, you will see that magically all these ROS topics now have TB3 on them. Same thing. So if I now want to add in some other robot, let's say the leatherback, and okay, there we go. Now, if I hit play, you can now see that there's a bunch of new topics like these. So again, it's super easy. Just go on leatherback, click on add attribute, and this will already show up because we've done this before once in the simulation. So again, click add again, and then scroll all the way down. Let's name this leatherback. So now if I've stopped the simulation, let's hit play again. And let me just clear the terminal here. So now if I do ROS to topic list, you will now see TB3 is set up, leatherback is set up. So super simple, right? Another quick thing I can demonstrate real quick. Let's take Turtlebot. Let's take the Turtlebot and let's duplicate it. So I'm just going to click duplicate. Now I have another instance of this robot. Now if I scroll in to the property panel again of the second robot that I just duplicated, you will see that it has the namespace attribute. Now, of course, this is going to collide, right? They're all publishing to the same topics, these two robots. So maybe we can do TB3 and then say robot 2, anything really. Hit play again. There we go. Now let's do a ROS to topic list. And now you can see, TB3 robot 2, TB3. So it's really that simple. So there we go. Another really quick thing I wanted to show. We have
a quick question here, Ayush, if you don't mind.
Yeah, go for it, please.
What's the significance of actually stopping simulation and hitting play? Like, I know it's tied to like the action graph stuff happening in the backend. Like for users who are not familiar with action graph or even like ROS graphs in general, like a quick overview, I think would be very helpful for people to understand like how they can actually utilize like the ROS OmniGraph nodes in their workflow and stuff like that. So it would be interesting to cover that too.
Absolutely, that's a good question. So let me open up one of the action graphs that we have. So just to kind of quickly go over this, action graphs are kind of the way we interface with ROS in Isaac Sim. So we have all these different graphs that are set up, and it's just flowing the data. So here, for example, you can say that on each simulation playback tick, which is when I hit play, I will run the subscriber ROS node. And then the subscriber ROS node is looking for something under a certain topic. It is then receiving those commands. So in this case, it's receiving commands from Ackerman Drive. and then it's publishing them or sending them to the Ackermann controller. That's another node that we have in Isaac Sim. And then once the controller comes up with the wheel angles and the velocities, those are then passed on to the articulation controller nodes, which are then controlling the robot individually. So this is kind of an example of how we have a ROS action graph. And now Rishabh mentioned, stopping and playing sim. The reason we want to stop and play it again is because every time we make some sort of big change, like topic names or name spacing or anything like that, we actually cache it on the first play so that we're saving on performance for the simulation. So we would rather, so that's why you'd have to stop sim and then replay it so that the cache gets updated with the new topic names and the new namespaces. And so that's why it's always important anytime you're doing anything with ROS to, you can change things on the fly, but they're not going to get updated unless you hit stop and play again. And this is normally okay because no one is looking to, change topics on the fly as, you're running your workflow. So that is the reason why we do this.
Right. Thanks for that. I think it makes sense for sure because, like, I know we've seen people in the past, even on forums, like, uh, one of the first things we usually ask people is like if they've stopped simulation and restarted it once they've made changes in the action graph, because, like, I think inadvertently people expect like the simulation is playing in the background and they actually make changes, but when they go on the raw side and they're able to like see the topics and actually visualize what's happening there, things remain the same. So I think it's important to remember that stopping simulation plays that important role of making sure that you can update the parameters correctly. And then once you like hit play with the updated things, you should be able to see it reflected on the raw side, maybe in RViz or wherever you're visualizing data or even through the algorithms directly. So, and like Ayush mentioned that the OmniGraph nodes here, which are a part of like the ROS2 bridge extension, are really helpful. And we have many of them already available with IsaacSim, right? And I think it's also possible for users to write their own with custom implementations for like Python, C++ stuff in OmniGraph nodes. So uh, Ayush can probably walk us through more details over there too.
Yeah, absolutely. So I just really quickly want to show you like the different OmniGraphs that we have that are available already. So there are kind of two types of OmniGraph nodes that we have. One is just the generic publishers, right? So, these are just all the different types of publishers we have, like ROS2 publish image, for example. And then we also have different types of publishers like the camera helper node. And this is another OmniGraph node. And also the camera info node. We also have one for the LiDAR helper. So helpers are really important because when it comes to anything that's synthetic data generation kind of type things, so which would be images or LiDARs, those are set up in a really complicated synthetic data generation pipeline. So for example, if this is already set up, so in one of the graphs here, let's say I'll open this one real here. Okay, so we have a sensors graph for the leatherback. And inside here, you can see we have a LiDAR helper. We also have a camera helper. And what we want to do is, publish different images and also publish some LiDARs, right? So if I hit play, and now if I pause it, what this actually does is, this will set up a very complicated synthetic data generation pipeline graph under the hood, which will then actually have your image publisher set up inside it. So that is what I'm going to show right here. It's this graph here called render post-process synthetic SDG pipeline. If you open that, which will take a while because we have many, many nodes.
I remember seeing this graph. and I used to mind going full screen. I think that might help with actually.
You're right. Okay, so there we go. So now we have this massive graph here that was created with all the synthetic data generation publishers. And if I just scroll in really quickly, like here, for example, we have a publish image node. And this is being, connected to an Isaac RGBA to RGB node, which is kind of what we do to convert some of the, RGBA data that we're getting from the synthetic data generation pipeline, right? And so these buffers are being passed in, and then these are GPU buffers. Sometimes they're CPU buffers, and we like to optimize things. So we will usually pass around GPU buffers, and we kind of do all of this magic underneath, so the user doesn't have to. Which is why we always suggest the user to, rather than publish images or anything by themselves using a generic publisher, for example, it's better to try to use our own publishers that we provide because they will usually be optimized. and they'll like performance wise, it'll be a lot better. So that is, yeah. So this is this massive graph that hopefully you should never have to touch.
Yep, I think I
Because
was just going to highlight that. Thanks for actually bringing up the graph, but I would want to make sure that users understand that you do not need to go and tweak this graph, because like once you're using like the camera helper, for example, with ROS2, and you're specifying like the topics and all the type of information which needs to be published, this is going to be auto-generated under the hood. So if you're
yes,
curious, you can actually go and see what's happening, but you don't need to actually go and make changes. So that's just more of like, oh, this is how it's done, rather than go and change this and maybe worry if things don't work. So
exactly, because you will see some crazy nodes like this one here that has so many inputs and outputs. So luckily these are all auto-generated, and no one has to manually touch these. But yeah, as Rishabh said, like please don't try to go and modify this graph unless you absolutely need to, but you should never need to. So yeah, okay, great. So I think that's pretty good in terms of what we covered for synthetic data generation stuff. There's just one really quick thing I wanted to highlight for the namespace, and then we can, I think, get started with the questions. And that is, for example, if we look at a, so here, let me half screen this again. Okay, so like I mentioned, automatic namespacing, right? So we have, namespacing that's automatic, which is great. But what if you wanted to, tweak your graphs so that not all graphs are automatically using namespaces? And the way we do that is actually quite simple. You can just go to some of your publishers. Like, for example, I have a camera helper here, and you'll see that it has a namespace. So now if I set up anything like my custom namespace inside, which is the old way of doing things. If I set this up and I hit play again, you will now notice one of them will actually have this custom namespace set up, or it should. Let's do this. Well, that's interesting. Okay, let me try to stop and play this again. There we go. Okay, so let's try this again. Okay, I wonder why that is. I think this is probably because the render product for the LiDARs are not enabled. And the way we can check this is by opening the graph and quickly checking what we have. So if I have this, right, so there we go. So you can see how this is disabled. Because it's disabled, this graph is not going to be activated. So when I actually passed in whatever namespace I had, it didn't matter because this graph was not enabled. So what I'll do instead is hit check this, enable it. I'll hit play. And now I will run this again, and hopefully it should start showing up very soon. If it doesn't, then there's probably some other setup that I'm missing at this point. So let me actually look at another graph here. So for example, this one, because this one, leatherback. Okay, RGB, great. So this is already enabled. We know that for sure. So if I set this up and say my custom namespace, there we go. There we go. So now you can see that my custom namespace is set up here, and it actually, overwrote what you had underneath here as well. So that's like, if you're worried that, it's going to overwrite all the settings you have, it's really not. But if you don't have anything set up, then it will overwrite it, is what I was trying to get at. And one more thing, and then I promise we'll get to questions. That is, if I have a camera publisher, and that camera lives under this tree structure, right? We have leatherback ROS, and then we go under this node called chassis, or this prim called chassis. And underneath chassis, we have all these different cameras. Now these cameras actually live right here, and then the helpers will, have the path to this camera set up, and so it knows where to look. Now, if I set up my namespace to be underneath chassis, for example, if I want to set up another namespace, I can just simply do that. I can just do add attribute Isaac namespace, and then I will set it to, let's say, chassis, or let's do my chassis, right? Now I'll hit play, let me clear this. And if I do ROS2 topic list, let's give it a moment again. Sometimes it does take a while to update. So once it updates, there we go. So you can now see my chassis is now being constructed as well. So we had Leatherback, which is the top level. Then we have my chassis that we set up. So this is, again, something I wanted to show that, look, like you can have these different, sub namespaces set up. And based on where they are within the tree of the stage, you will then construct these namespaces. And that's also another way to automatically do it. And why do we have this? Is so that if you have, say, something that lives under a chassis kind of prim, and let's say that's in a different USD. Like, for example, the camera has its own USD. I will drag in the camera USD, and now it'll be under its own tree. So these trees will then kind of, when we actually compose them, we will then use the namespaces that are set up so that it's like clear which camera, for example, or which place it's coming from, or where the camera is originating from. So that is kind of it. So that's kind of the demo that I wanted to show. I think we can probably start going to questions now.
Sounds good. Thanks, Ayush. I think automatic namespacing is pretty useful. Like I know in the past where like this is not really a problem like you see when you're having like only one robot working with ROS, but as soon as you have like more than one, and now you are actually going in and making changes in action graphs manually for each of those robots, I can see how that scales up and like turns out to be like a tedious problem to solve. So I'm sure this certainly helps over there. And yeah, we can get started with the questions, I guess. Let me actually find the first one. Okay. There is a question about RL. Hi Taylor, I have a question about RL for multi-agents with ROS2 and randomized agent locations and environments. We're having issues with implementing a reset with randomization and ROS2 packages such as nav2 and AMCL. Okay, I'm not sure what the exact issue is. Is this more like an of an Isaac Sim side of an issue, or like does this seem to be like a ROS to generic package sort of an issue? Ayush, what do you think? Like, what's the best way to go about this?
So to me, it sounds like it's probably a bit of both. The first thing when they mentioned that they're having issues with resetting with randomization, and then also like nav2 nav2 and AMCL particularly. I know that if you are running the stack and you reset simulation, your timestamps will reset, and that will cause nav2 and AMCL to freak out. So usually it's not best to have nav2 or AMCL or any of these kind of nav-related packages to be open while you're resetting simulation. So you should always close your stack, place them again, and then reopen your stack. Now, if you can't do that, or if you don't wish to do that, there are certain ways we can kind of get around this. One is to make sure you're publishing in monotonic time from simulator. So this way, like regardless of whether you stop or play sim, the timestamp will always be increasing and not resetting to 0. This is like not a very niche use case though, so most people don't use this. It's better to just reset simulation to 0 because that way it's kind of deterministic. And so, yeah, so that I think maybe is a way you can kind of get around the issues with nav2 and AMCL. When it comes to reset with randomization, I am not exactly sure what the issue is here. Maybe it's I'm not exactly sure. This would
Right,
be
because
more
like I
about.
think that was a question also in my head, like in terms of like resetting or even like randomizing things while navigating. Like imagine like you've got nav2 and you've like spawned the entire map of the space which you're like running nav2 in, and like somehow you manage to like maintain that time continuity and you randomize the location of objects inside it. I'm guessing like navigation also might just go berserk over there, because like within a split second the location of objects inside the map are changing. So unless like they're static slash dynamic objects, I think like randomizing them also might be challenging in general with navigation. So when you actually do construct the map, for example, with Slam, and you have like objects which are preset in locations inside your simulation environment, like they show up correspondingly as the static objects in your map, right, when you're running a navigation offline. And when you actually have newer objects added inside the scene, like they are picked up by your LiDAR or by your point cloud camera, stuff like that, and then your navigation is actually handling like the stack around it. But what if the static objects itself change? I guess like in that case, even localization might be thrown off completely. So navigation just in general might fail. So it really depends in terms of like stopping simulation, I think is like one important thing which you mentioned as well, like before randomizing things, stopping and resetting simulation, and then also making sure like the right objects are being randomized when you're trying to do something like that. So I hope that makes sense.
Yeah, I think Rishabh explained it well.
Okay, we can go on to the next question now. Okay, we have Arjun. Hi, I've tried multi-robot setup in Isaac Sim before and the FPS drops significantly. Please let me know how we can get more than 40 FPS if there is a multi-robot setup in simulation mode. Uh, okay, so Arjun, I think like is this like a general robots and Isaac Sim question, or is it more like around ROS? Because like that would be the first thing, because like ROS certainly does add an overhead in general when you add in more robots, and especially if it's got like sensors like cameras, lidars and stuff, which add more overhead in terms of like simulating the robot itself, and that significantly does affect FPS. Or is this like a more general question where you have like maybe a turtle bot which has got like one 3D or maybe one Intel RealSense camera and one 2D lidar, and you keep adding them and then you're seeing significant performance drops? So I think the situation in both the ways is really different and depends on sort of the overhead, even on the ROS side. Any particular insights, Ayush? Maybe like we could also address this from the multi-robot navigation angle, like when we have more than one robot. For example, I know like we have independent nav stacks running as well independently for those robots, and that adds like CPU overhead also in general, and then also like the overhead for actually simulating multiple robots. So I think like multiple things which could make potential options in terms of actually solving this problem. Any advice for people to actually get the most of what they have in simulation?
Yeah, so I think the main bottleneck when it comes to, FPS is usually images, actually. Like if you're trying to send many, many images, for each image that you're publishing, you also have to create a render product in Isaac Sim. And that's, again, it's done under the hood. But for each render product, that actually uses up a lot of your GPU and a lot of your CPU. So I would say, if you really need images, try to, limit them as much as you can. Unless you actually need them, then of course use them. But that's one. The second thing is that there's also a difference between essentially sending data over shared memory in ROS versus over UDP. So if you have two computers that are talking to each other over a network, then you have to use UDP. So whereas you have a ROS subscriber on one of your computers and then you have Isaac Sim running on the other, then you will have to use UDP. And this process is actually quite slow in ROS. And that it'll actually, what we have seen is that it actually creates back pressure onto the simulator. So let's say your subscriber, because it's over UDP, it's slow. Your subscriber isn't receiving these images in time, or it's not processing them in time. So then, your ROS QoS, like your ROS queue will fill up. And once it fills up, it'll actually slow Sim down. And because Sim is not going to skip frames, it's going to wait for a ROS to publish before it moves on. So that is one thing to note. So if you do use, try to use shared memory support, we do have something in our docs to mention that mentions that. So yeah, try to use shared memory transport. And if and all you need to do for shared memory transport is not, source your FastDDS XML file, because by default shared memory is set up, and try to use your ROS stack on the same machine as Isaac Sim. So that way shared memory is enabled. And if you do have that, then your FPS should increase a bunch. But of course, like again, try to limit as much image publishing as you can. We will eventually get to, enabling compressed image support. So that should help a lot, because publishing raw images, it's a very, very big packet that you're sending. So yeah, I think that's probably some of the things I would mention when it comes to improving your FPS. You can also, I guess one thing that also comes to mind, you can also try to skip image publishing frames. So like we have a thing in our camera helpers that's lets you skip an n number of frames. So every x number of frames, or every whatever, you can set it up that way to kind of help you. But if skipping frames doesn't help, then what I mentioned earlier is probably the best thing to do.
Makes sense. Thanks, Ayush. I knew like cameras and even I think like lidars in general have like the most overhead. Even like if you add like 3D lidars into the scene, I'm sure like just given the amount of data which needs to be like even published / subscribed over to ROS, like that itself adds a huge overhead. So those things certainly affect the performance drastically, and they will show up more prominently when you've got like multi-robot setup. Because imagine even if, like with the Carter robot, I think with the Nova Carter, for example, like more than 5 sensors, like in terms of like 3D lidars, 2D lidars, and then RGBD cameras as well, like sending over RGB, then depth info, then point clouds, all of that. I think like that really adds over a lot of overhead in terms of like publishing and subscribing data. So multiple robots of those similar types where you've got sensor overhead, like certainly drastically affect performance. I think we have the next question, which was also similar to that. We can bring up. Hello, is there a graph node that loads policies to a robot? I don't
So
think we have one directly, right? Do we have anything?
this is an interesting one. So no, we don't have any action graph nodes. The way you would load policies probably is to just make your own extension and then load your policy there. If you really, really wanted to, though, you could create a script action graph node, and inside your script action graph, you can put your policy there, and then the outputs and inputs you can set up manually, and then do it that way. But yeah, that is kind of, I think like extension workflow is probably the best way to do this. Otherwise, if you have, if you're using standalone, then that's also easy because it's just scripting. So I think
Yeah,
those are the
makes
two
sense.
main ways to do it.
And what would the reason be to actually recommend like the extension-based workflow instead of like the regular OmniGraph approach, where, for example, like maybe I write a custom Python OmniGraph node myself, and I specify like the input. So maybe like my policy needs like the robot state, maybe images from the simulator, and maybe reading from an IMU. Just a hypothetical case, like that's what my policy needs, and probably needs the actual path of the trained policy, which could be like a PyTorch file, or whichever platform it was trained on. So uh, what would the difference look like on actually in terms of like the workflow for using like an extension versus like OmniGraph node? Like, do you think like there are any trade-offs to consider over there? Like, which one would be better, and how do you select the best way?
I think it depends on what you're looking for. So if you want really want the action graph interface where you have all these different inputs that are already set up for you, you just drag them into, sorry, these different outputs, and then you just drag them into your own inputs. That is definitely a way to go. And it's definitely doable. It's like, I'm not saying it's not, but for extension workflow, I think it makes it simpler to set up. So it'll be a lot faster to set up because you just have this script, and then you have these different callback functions within that script that interact with how your simulation is running. So that's probably just the easiest and way to go. And like I mentioned, the other one is standalone. So I think that one is actually, that might be the best one because it gives you full control of the simulation. So you can step the simulation whenever you want, however you want. You can also interface with your other action graph nodes to grab your data, and then via script, you can then pass the data that you just grabbed from each of your action graph nodes into your policy, and then output that, and then pass that into your robot within the standalone script. So I think that's one. The main difference, I guess, between standalone and extension, though, is that extension, you don't necessarily manually step the simulator, right? So that one is just set up. It'll run at whatever optimized simulation settings that we have. So that's usually we try to reach 60 FPS. So it'll kind of run at that rate. But it's also interactive. So GUI wise, the GUI would work and everything. So that is one thing. But with the standalone, it's like the GUI is not necessarily as interactive as it could be just because we give all control to the script. So yeah, I think that's how I would look into things.
Makes sense. Thanks. I think it also makes sense, like in terms of understanding what the exact requirement is, right? Like to load the policy itself. Like, what if you want to actually have it with the USD? So, for example, I've got like maybe I've trained a quadruped to walk, and that's the policy which I've got for that, like the quadruped itself. So, In that case, if I'm like hoping to have like drag and drop functionality, then my approach might be like different, like in terms of me wanting to add this particular robot with the policy inside any USD, then maybe like an extension plus action graph approach might make sense, or like vice versa. So I think like all the three options do exist in terms of like standalone extensions or like in terms of OmniGraph, but depending on what sort of target application or use case you're looking at, you could play around with the combination slash individual ones over there. Thank you. Okay. We're interested in the potential use of Isaac Sim and ROS2 workflows in technical educational and vocational training. Do you think it's feasible to create simulated environments where students can interact with virtual robots to learn ROS2 programming and real-time control, even without access to physical robots? Are there any use cases or resources you would recommend for this purpose? I think this is certainly possible, right? Given that you can use either a simulated robot or a real world robot to actually like even understand ROS2, for example, and the ways which you can like utilize ROS2 interface with the robot itself. So I think the tutorials which we have on the Isaac Sim docs itself for like ROS2 would serve as the ideal starting point to understand like what the overall workflow looks like with ROS2 in terms of like basic understanding of the ROS2 bridge extension, for example, and then the OmniGraph nodes which we have. And we've used like the turtlebot example over there, which will allow you to like walk through a particular sample from end to end, and that'll allow you to actually learn even the fundamentals of ROS2 in some sense with a simulated robot. So that is certainly possible. And for resources, I think like our documentation and tutorials which we have for ROS2 are the best points to get started. Anything you would like to add over there, Ayush?
No, I think you covered it. Just really quickly though, Turtlebot is probably a good robot to start with because we have like it's also easy to get a real Turtlebot. So if you ever wanted to, especially for ROS programming, you can try it out in the simulator first, and then just plug and play in your other Turtlebot in the real world. And the sim to real transfer shouldn't be super complicated because it's a Turtlebot and it's already super standardized.
Makes sense. So yeah, I think this should be certainly doable, and uh, actually having like students learn to do this in simulation usually makes sense first as well. I think like even looking back at my own learning journey, I think simulation was like the first place where you actually get started with like even understanding like the basics of algorithms and robotics and even like kinematics, dynamic stuff like that. So you do cover a lot in simulation, and then like in an ideal world or even like in a good world, maybe you have access to the same robot in the real world and you are able to try some of it out on the real robot as well. But given that even access to the real robot might be like a problem in itself, simulation I think is like a pretty good place to get started with. And for the use case just described, I think it should be very straightforward to get like Isaac Sim up and running with ROS2 and actually understand how the whole workflow looks like with the Turtlebot, for example. Let's look at the next question here. When designing an action graph setup, is it generally recommended to consolidate everything into a single action graph, or is there an advantage of splitting functionalities across multiple action graphs? This is a
I
good question.
Yeah, this is a good question. Like performance-wise, we used to have issues where if you have multiple action graphs, then things would be slower. That's not the case anymore. So I would say split it up as much as you want if it makes things easier to read. Usually we try to split it up based on sensors or function. So I think it just makes sense to split up action graphs so it looks nicer and it's easier to read. Because if you have a giant action graph, you'd have to it'd be just harder to read for you. So it doesn't necessarily matter.
Makes sense. And is there any recommendation or like guidelines from our side in terms of recommending the split up itself, or like it doesn't matter at all?
Yeah, like I said, it doesn't really matter. I would say like the way we have been doing things for our samples is split it up based on functions. So lidars have their own graph, for example. Cameras will have their own, or you could split it up based on sensors or driving, certain things like that. So yeah, it's just up to the user to figure that out, however they wish.
Makes sense. Thank you. Can look at the next question. Is it possible to edit the auto-generated nodes, or is it read only and just to give an under-the-hood view?
My guess is they're talking about the synthetic data generation pipeline. So if that's the case, then yeah, it's absolutely possible to edit your auto-generated nodes. We do actually recommend some people to do it based on their needs, especially if you're trying to like skip frames or do anything else. You can definitely go ahead, like open that SDG graph and edit the nodes. But one thing to note though is that because it's auto-generated, those settings are not going to be persistent. So if you hit stop, that graph disappears. And then once you hit play again, it'll just auto-generate that node, but your settings will go away. So if it's like a quick thing that you can just edit, then go for it. Otherwise, you can always do it via script, right? So every time you hit play, the script will also edit the SDG graph. I mean, it's not recommended to edit it, but if you do, you're like, yeah, we're not like nothing is stopping you from editing that.
Right, I think that was a good catch because I was confused like what auto-generated nodes are being referred to over here, but I think like given like we walked through the SDG graph which was generated under the hood for like the ROS publishing stuff, it makes sense. And I think like Ayush mentioned, like those things are not persistent. So if you actually do go ahead and make the changes and you stop and maybe you open the stage again and you're going to hit play, like those changes are going to disappear. So the more persistent way to actually do that might be through like actual scripting in terms of like either the script editor or through standalone scripting, whatever suits you. But you really need to be sure about your exact use case and need to actually go deeper and make those changes. So okay, you can look at the next question. How do we get a real sense depth camera image in Isaacson? I'm going to let you take that one, Ayush.
This one is quite interesting. I think I'm not exactly sure if Isaac Sim has a RealSense depth camera like asset that you can just use that's already pre-configured. I believe we don't, but if we do, then yeah, it would be just in the asset library, and you can just drag that in. That's quite simple, and then you just set up your ROS action graphs. Like you can follow the tutorials to set up your cameras, and then do it that way. And now, if we don't, what I would say is look into the data sheet for the RealSense depth camera image and then find all the camera intrinsic parameters. Once you have those, you can actually go into the USD of any camera prim and then update it according to these intrinsic parameters. And once you do that, you can actually essentially get the same type of image that you would get off of a RealSense camera, but in the simulator.
Right, I think like for 4.2, I can find the link easily for like the real sense asset which we had, and I know like that gives like the fisheye view and like the intrinsic, extrinsic, like and all those things have been set for you. I'll probably look for the 4.5 version of that same asset, but that's certainly possible. And like Ayush mentioned, once you have the asset, I think like which has been set up with the right parameters, so like the camera is good enough, and then just hooking it up with like the ROS nodes which we have and making sure it publishes that same data. I think that should be relatively straightforward. But we'll look for the link and we'll probably put it on the chat once we find like the link to the asset extension, the assets itself, like the sensor assets. We can take a look at the next question.
Awesome. Thanks, Rishabh.
I think this is similar to the one which we had a couple of questions ago. Is there any impact in performance for separating into multiple graphs? And I think Ayush mentioned that
No.
it should not make any difference. So, okay. Can you talk more about zero MQ versus ROS? So, sorry, personally, I don't know what zero MQ is. Ayush, do you have any idea?
Yeah, so actually, we have had some work done with zero MQ, or I mean, I like to call it ZMQ. And it's actually, there is a GitHub that you can find on our Isaac Sim repo space where you will be able to launch a ZMQ bridge with Isaac Sim. And that kind of gives you an example of how ZMQ could be used to communicate with Isaac Sim. Now, when it comes to just talking about like zero MQ versus ROS, I would say like ROS is kind of the recognized standard for robotics when you're prototyping with robots, and ZMQ is more of a like very personalized way of communication, right? So there's not too much of a huge community behind zero MQ at this moment, but it is used by a lot in the industry, for example, to set up their robots and talk to their proprietary communication ports or whatever. And the other thing is also that ZMQ is brokerless, which means it's just peer-to-peer, versus ROS is a broker-based system because it has like a DDS in the middle that kind of manages the data flow. So like ROS again. So I guess to summarize, ROS is a big community. 0MQ is a little bit harder to set up because people just use it for their own use cases. It's not necessarily standardized. And again, but 0MQ could be better for performance if you're only looking to send a particular type of data through a certain channel, versus ROS is a standard. So you're going to have to adapt your data to match ROS's standard and then use that to send it over. So I think that kind of helps. I hope that answers your question.
Thank you. We've got another one on FPS. And by the way, I pasted the link for the RealSense asset into the chat, so that should be available. And it's part of ISXM 4.5 as well. So you should just be able to like simply drag and drop that asset onto your robot or like onto your stage in general. And once you connect it to like the necessary ROS OmniGraph nodes, you should be able to publish like that corresponding RealSense data to ROS as well. So that should certainly help. Coming back to the question, noticed a drop in FPS when adding more nodes to Action Graph. Is there a way to offload these computations as a separate thread to mitigate the impact?
This is quite interesting because I'm not sure if there's a way to do this at this moment. We have I guess you can always set up your graphs to do like vectorized computations. It's not that common, but it is there. So you can like set up your omnigraphs to do any sort of vectorized, assuming you're doing the same thing over and over again over multiple assets. Then like vectorized computations might be a way to go. But otherwise, yeah, I mean, you're just adding more functionality into your action graph. So it is kind of expected that your performance will drop a little bit. If you're looking to also just, increase perf, maybe another way is to come up with your own, like you set up one graph or one node that does a lot of these computations inherently. So you're not waiting for data to be passed from one node to another, which might be another way to like speed up your computation a little bit.
Makes sense. Thank you. We have setup question as well. Might be able to take that. No, chose best forum for it, but here it is. I have ISXM 4.5, Python 3.10, VS Code setup. Running the stacking example for the Franca robot, and it performs the stacking operation. However, in VS Code, the libraries are not identified. Underlined, for example, from isxm.isaac.core import world. I think it's basically like this VS Code setup instructions which are going to be needed here, right, Ayush?
That is my guess, yes.
Let me look for... I can paste the link in the chat, but this should be relatively straightforward. We can take the next question. Okay. Also, I see the CPU is getting used more than GPU in multi-robot setup. I'm guessing this was for navigation or maybe general multi-robot. Is there a way to offload it to GPU? I tried GPU dynamics and ISXM, but that didn't create a lot of difference to increase the FPS. I think Ayush, this is similar to the question which Arjun had asked earlier regarding like just more performance with multi-robot setups and maybe offloading things to GPUs. Do we have any guide for like specific cases where that can be done? Like I know even in the previous question you mentioned vectorization and stuff like that. That might help, but is there anything else which people can do from there and to get the most performance they can, even in terms of if that means like splitting things up between the CPU and GPU efficiently?
Yeah, so I think what Arjun has tried here is to set up GPU dynamics, like I guess physics settings for GPU in ISAACSIM. What we have seen is that if you do it with physics, like if you set up your physics dynamics to be GPU based, you will only see the perf gains when you have many robots. If you only have like 2 or 3, then yeah, your FPS isn't going to change a lot. So usually we actually recommend, if you're only going like 3 or 4 robots, use CPU based physics. because it'll be a lot faster. But if you have like hundreds of robots, right, that's when you start to use GPU dynamics. So I think that's hopefully that answers your question.
Makes sense. I think the next question we have is, what is a fine graphic card you would recommend considering prices? Would an RTX 3060 16 GB be good enough? I think we have benchmarks on the Isaac Sim, official docs as well, right? For like multiple GPUs in terms of like the performance you can get. I'm going to paste that in the chat, and that probably should serve as like a good reference for understanding what GPU might be suitable. And it also lists out like the type of use case. So we've got it for like SDG, ROS, and then like just general sensor stuff and corresponding complexities of environments with the performance. So you should certainly take a look at that, and depending on where your use case sits over there, that guide might be like the best place to look at. So I'm going to look for the documentation right there and paste it in the chat, while I'll make sure that we have the next question up on the screen.
I
So
think
Ayush,
as far as
sorry.
we can tell for system requirements, I believe the minimum requirement is to have a 3070 with about 8 gigabytes of VRAM. So, but you have 16 gigabytes, so maybe a 3060 could be enough too. But this is just something you'll have to try.
Yep. And I'm going to paste the benchmark link right here in the chat. So that should be helpful in terms of understanding even like KPIs on local hardware and stuff like that. You can take a look at that entire page. That should help. Let me actually look for the next question. Okay. Is it possible to use the Python API to get handles on existing prims even when launching Isaac Sim the standard way? From my experience, trying to execute an ad hoc Python script for control, for instance, scene elements, will cause Isaac Sim to freeze.
So this is definitely possible. It sounds like if Isaac Sim is freezing, you're probably not updating the simulation app, which many people you might forget to do. So like every time you do something like make a change to a prim, you have to make sure that you run the app.update call, or it would be like simulation app.update call, any of those calls like that. That way the simulation, like the app will actually like refresh all the USDs prims that are in there. And then hopefully that shouldn't cause that freeze anymore because nobody else is waiting. And one more thing you could try is to have your functions wrapped in an async call. We have noticed that if you set it under async, then you kind of reduce a lot of these issues.
Makes sense. Thanks. I think like even like the app update step you mentioned, I think like that even applies for like SDG and stuff like that in general, where you might be updating like for example semantics of prims on the stage while you're recording synthetic data. So stuff like that. Even there you want to make sure that you're running app.update. But any more insights in general though, Ayush, about like what happens behind the scenes in app.update, like the important things, for example?
Yeah, I think app.update will kind of do a bunch of things. So the main thing is that it'll refresh like I said, it'll refresh all the prims. So it'll have all the new prims in context, or new changes in context. It'll also, depends on which exact call you do. There are multiple calls. It'll either update physics or it'll update the rendering. And then that way you can actually move forward one frame. So we also have a function called step, which does all of these in one go, where you have rather than just updating the context, it'll also update the simulation and move it forward one frame, and that's called a step function. So that one will do that automatically. But if you're just making any changes to the settings, if you don't call app update, then yes, your Isaac Sim will likely freeze, or it'll cause other issues. I would also, like I said earlier, definitely try to wrap it in an async call. If you're running standalone, it doesn't matter. But if you are running in an extension workflow, then yes, you have to wrap it into an async call, so that we are not blocking simulation from moving forward by your function.
Thanks. Makes sense. We can look at the next question. As I have multiple quadruped robots with multiple sensors like cameras and lidars. What do you suggest to simulate something like that with and without ROS? Need to generate training data. I think all of this should be doable with Isaac Sim directly, right? Like you've got sensors which are already supported. If you've got like your robot represented, maybe URDF or a different format, you should be able to bring it into IsaacSim. And we also have like the necessary ROS bridge extension and like even the corresponding OmniGraph nodes, which would be useful. And for generating training data, I think like for the camera and LiDAR side of things, you can use Replicator, which will handle like getting like access to the ground truth data with the annotations. And for physics stuff as well, you should be able to get it directly through IsaacSim API. So you can write your own custom annotators with Replicator, for example, and maybe in one cycle where you're actually getting the data, you could be getting like camera data, LiDAR data, and the joint states of your quadruped. So all of that can then be directly written onto the disk with a replicator, or you might want to even connect it directly to a training pipeline with Isaac Lab. So it totally depends in terms of what your actual workflow looks like, but all of this is certainly doable with Isaac Sim today. And anything to add on top of that? Are you sure you think that's good?
No, I think you kind of covered all of it. And I'd like to say, right, like with ROS or without ROS, that's kind of up to you. If you're using scripting within IsaacSim, you don't necessarily need ROS. But if you have another process that's living outside of IsaacSim, you might want to use ROS to transfer that data out of the simulator.
Makes sense. We've got a not related to ROS2 question. We'll try our best. While importing assets from Unreal 5.5 to IsaacSim via USD, Surface Normal sometimes appear wrong. Omniverse Connect plugin works, but that is available only for 5.3. How to fix? I'm not sure I've worked directly with assets from Unreal into IsaacSim before. Any idea from your side, Ayush? Or maybe this question might be more suitable for the forums. We might be able to pull in someone who might be able to help.
Yeah, unfortunately, I kind of only deal with ROS2 stuff. I haven't worked with Unreal before as well, or connecting that with Omniverse. So I would say, yeah, please post this on the forums, and we'll make sure someone answers your question quickly.
Yep, thank you. Is there a standalone example for performing pick and place operation with a Panda arm running in IsaacSim? I think we've got with the UR arm, pick and place for like warehouse applications. And if we actually go inside the example itself, it should be straightforward to actually load like the Franca robot instead of the UR robot, and just make sure you're utilizing like the pick and place controller, the articulation controller, and all the corresponding elements over there, and just swap in, swap out with your robot. So let me look for the example which we have for pick and place, and my guess is it should be easy to swap any robot as long as like the corresponding pick and place controller works with that robot. Anything else you want to add over there, Ayush?
Yeah, so we definitely do have an example for pick and place. While it might not be a standalone example. Quick thing to add though is that you can just, it's all the same API, so you can just copy and paste that into your standalone workflow, and it should just work. The main difference being that like if it's an extension workflow, it'll have like async functions set up, but in standalone, you don't necessarily need to set it up as an async call. So you can just put it into any function you want.
I think we are also approaching the end of questions, and also almost the hour. So we'll try to run through the last few ones quickly. Edmar.
This is great. I mean, you guys are really tackling a lot of questions here. So thank you so much.
We're trying our best. Okay, we have a ROS2 question again. I tried publishing the object data from IsaacSim to a ROS2 environment, specifically move it to. I wanted to see if the robot inside IsaacSim senses the object and remaps its path, but it's not working. Is this referring to like the simple move it tutorial we have with IsaacSim? I think Ayush, this is probably what that is, right?
I'm not exactly sure what they mean by object data. If they're talking about like point clouds or something, our example in Move It To doesn't actually have, it doesn't support point clouds or anything like that. We only like publish the trajectories from Move It into Sim, and nothing more. And yeah, at the moment, actually, because of some issues that we're seeing on Move It's end, this tutorial is kind of a little bit deprecated. So we are looking into updating this tutorial for something that works for us. So yeah, I would suggest try it out. If it's not working, I would look into what inputs the Move It stack is looking for. Sometimes it could just be like topic names that are not matching, or like a type of point cloud that Move It is expecting but we're not getting. So yeah, I'm not necessarily sure because this isn't something that our Move It 2 tutorial actually does.
I think Prajwal has updated his, like you can see a comment. He's like, he does not want access to point cloud data, prim data. So I think you would need to just make sure like you're subscribing to that corresponding information, and if you actually want to make changes to the USD itself on the basis of that, that should be doable as well through scripting. So there might be a few pieces you would actually have to develop yourself in that process, because like I don't think we've got a ROS2 subscriber, right, Ayush, which can subscribe to something and move an object like a USD object on the stage.
No, actually there is. So we do have a
Okay.
ROS2 TF subscriber. And I think that's probably the best way to do about things. You just put in this ROS2 TF subscriber in your graph, and that'll actually move things according to your TF. So yeah, I would suggest try that out. You can also publish the prims directly using a TF publisher as well. And then you can actually look into that like inside your Move It stack as well. So yeah, try using TFs and try using the TF subscriber node as well.
Makes sense. Thanks, Ayush. I think we can take the last question. Probably we've got a few other ones on there. Maybe we can take them next time, or like have them on the forum. But I think like the last one is probably important because I think we see this on forums as well in general. Is it possible to set up ROS2 on Windows using WSL2 and ROS2 on WSL Ubuntu? I tried it, but there was no connection between IsaacSim and ROS2.
So we do have we have a setup example that we have in our docs. So if you actually go into the IsaacSim ROS2 setup page, you will actually, and then if you click through all the tabs and select Windows, you will actually see a setup that helps you do this. And there are a bunch of ports and stuff that are blocked automatically by the Windows kind of networking system. So we have to make sure that those ports are open, and that's why the setup that we go through in our IsaacSim docs will help you unblock that, which will then finally enable connection between IsaacSim and ROS2 on WSL.
Yep, thanks for that. I'm just pasting the corresponding doc link in the chat right here as well, so people can take a look. But yeah, we have those instructions in the IsaacSim ROS2 installation setup page itself, so that probably is going to be the best place to unblock you.
Now, I also just see another follow-up question from Chintan as well, and it asks, would you recommend doing WSL or dual boot with Ubuntu? I would say WSL is a little bit limited, like I mentioned, because of the port blocking and all of that. So and also you're not able to source your own ROS installation. You can only use the libraries that we provide in Windows. So yeah, to answer that question, I would say try to dual boot on Ubuntu. I think Linux is kind of the best experience.
Yeah, I think I certainly agree with that. And also given like, yeah, networking issues and stuff like that, I think that also turns out to be a problem, and it's more easier to move around with Linux than debugging WSL issues, especially if you're just getting started with IsaacSim and even ROS2 in general. So that's probably the best way to go. I think we got most of them, Admar, and I think for the other ones, I think there are a few ones which are more around Isaac ROS maybe in general, and probably posting them on Isaac ROS forums might be the best bet, because they fall more on like co-motion, and those things are more of perceptor manipulator side of things, which you can work with IsaacSim for those products for sure, like when you're doing simulation. But if the specific questions about like how is a certain package designed or what may be going wrong there, Isaac ROS forums are probably like the best place to go over there. So
Great advice. We also have been posting the official support forum for IsaacSim. So any questions that you need to dive deeper from the discussion today, or if there's a new question, the IsaacSim support forums are the great place to go. For anyone who's working on Isaac Lab, that support area is actually not on the forums. Might be a little confusing, but that is handled on the GitHub page for Isaac Lab. So we'll post that as well. And then we also have, I think, an office hours coming up for Isaac Lab our producer who's helping on the chat today, Amelia, is putting that together now. And I think the plan is potentially next week we'll have an Isaac Lab office hours, same day and time as today. So that's something to look forward to. All right. Did you want to take any more last questions or leave everybody with any parting words of wisdom?
I just pasted the answer to one of the questions we had. I think someone asked about like drone simulation with Isaac Sims. So there is a simulator called Pegasus Simulator, which is built over Isaac Sims. I would certainly recommend taking a look at that for like drone simulation. And I'd like to thank Ayush first of all for having answered so many questions, especially around more deeper dives with ROS 2. And thanks for having us, Edmar.
You guys have an open invitation. Anytime you want to come on, I don't care what day of the week it is, or time it is, you guys just let me know. We'll pop on live. Thank you so much, and not only to you two, but all the amazing viewers, developers out there watching this live stream and engaging on the chat. Not only asking your questions, but I have to give a big thanks to some of the developers out there from our community. I can see like Papa Chuck and others helping answer some people's questions in the chat in real time. So that's amazing. And that's actually a great benefit of jumping onto the NVIDIA Omniverse Discord server as well. A little different than the official support forums, of course, because that's where the NVIDIAns are basically assigned tickets and everything. They could track problems. You can go to the NVIDIA Omniverse Discord, where there is a channel for Isaac Sim, and Isaac Lab is actually a study group that Amelia posted earlier in the chat that meets once a week on Isaac Sim and Isaac Lab. But there's separate channels for these topics, and you can get an amazing amount of wealth of information from other users. It's great to see so many users helping each other. And I will say that developers of the team sneak in there once in a while, also help out people. So don't be surprised if you see NVIDIA in there helping out in the Discord. Yeah, it's a great comment. Thank you so much. So thank you everybody for watching. Hope to see you next week, same day time, where we might be doing Isaac Lab. If you're ever unsure about our schedule, we have an ad event page where all our live streams and events are posted. Also accessible on our Discord server at the top left under events. We always post things there as soon as we have things confirmed. That's a great thing to keep an eye on. Thank you both. Really amazing hour. It flew by. And thank you all again in the audience for joining us today. It's been a pleasure.
Yeah, thanks, guys. It was a pleasure seeing you all.
Thanks, everyone.
It's great. And until next time.